Proposition 14, Book 2, Euclid. To construct a square equal to a given rectilinear figure. So here we have our given rectilinear figure, and we need to construct a square equal to this figure over here. So first of all, we know from proposition that we had demonstrated already, that says that we can construct a parallelogram equal to a given rectilinear figure in a given angle. So let's say that our given angle is a rectangle, a right angle. So we're going to construct a parallelogram sorry for drawing a parallelogram on a given angle. So this parallelogram over here is equal to this given rectilinear angle figure. So now what we're going to do is we're going to extend this, and now we're going to take this whole straight line and bisect it. We know that we can do that. So it's bisected, and we're going to draw a circle, taking this as the center, let's say. So we're going to draw the circle. It's not so perfect, but okay, let's say we draw the circle. This is our circle. Let's say that we continue here and we draw a circle. So what we're going to do next is extend this until we cut the circle, let's say, and let's draw this circle over here, and we're going to connect this point with that point. We can do that. And so as this is a radii and this is also a radii, so this is equal to that. So we also know that this is a right angle, this is a right angle, this is a right angle, because it's a parallelogram and angles on the same side equal to right angles, right angle, right angle, opposite right angle, right angle, right angle. So this is a rectangle, let's say, and these are the right angles. So we know that this is equal to this. After continuing, what do we have here? We see that this whole straight line is cut on equals and unequal parts. So unequal parts and equal parts. What does that mean? It means that the rectangle contained by this straight line, the given straight line, and the added part plus the square and a half is equal to, the rectangle contained by the given straight line and the added part plus the square on the middle segment is equal to the square and a half. So what do we have here? And we know that this is equal to this, so therefore the square on this is the same as the square on this. So we have that the rectangle contained by the given straight line plus the added part plus the square on the middle segment is equal to the square on this. Okay, so what we have here also, we have that this triangle over here is a right angle triangle. Therefore, from Prop 147 we know that the square on this plus the square on this is equal to the square on this. Oh, and we also know that the rectangle contained by this and this plus the square on the middle segment, or the square on the middle point of sections, is also equal to the square on this. Therefore, two things equal two things, the rectangle contained by this and this plus the square on the segment in the middle point of sections, and the square on this plus the square on this, these both are equal to the square on this. Therefore they're equal to each other. So the rectangle contained by this given straight line plus the added part plus the square in the middle point of section is equal to the square on this plus the square on this, and we see that they have common things. So let's subtract this from both, and we will have the rectangle contained by this, and this is equal to the square on this. I'm sorry, at the beginning we made this equal to this. So what do we have here? We have that the rectangle contained by this and this, that is the rectangle contained by this and this. Oh, and this is a rectangle contained by this and this, or the rectangle as the same as saying that is the rectangle contained by this and this, is equal to the square on this. Oh, so this rectangle is equal to the square on this. So if this rectilinear figure is equal to this rectangle, and the square on this is also equal to this rectangle, so this rectilinear figure is equal to the square on this. So thus we have shown, thus we have made, we have constructed a square that is equal to a given rectilinear figure. Thus we have shown now that it is possible to construct a square equal to a given rectilinear figure. Quod erat faciendum.